Welcome back. This is an Aleks training video on identifying hydrogen bonding interactions between molecules. A hydrogen bond is a very special kind of interaction, intermolecular interaction, where there is a hydrogen that's being attracted to either an oxygen, nitrogen, or fluorine. So oxygen, nitrogen, fluorine are very electronegative. Remember, they pull on the electron more than other atoms do. So very, very strong pull for an electron. And then you have an electronegative atom attached to a hydrogen. Now what's happening is that hydrogen, along with the electronegative atom it's attached to, acts like a magnet for other electronegative atoms. So if you have a hydrogen bonded to an oxygen, fluorine, or nitrogen, and then it encounters another molecule with an oxygen, nitrogen, or fluorine in it, it's like a magnet that'll attach. And so many biochemical bonds are hydrogen bonds. Lots of oxygen, nitrogen, fluorine in organic. So it's used like almost like a Velcro, where it'll hold together things that could be easily broken by an enzyme. So there are two tests that you're going to see that you're going to need to pass in order for you to know that there's a hydrogen bond. The two tests are each molecule must have one of the strongly electronegative atoms of oxygen, nitrogen, fluorine. So the two molecules in question have to have an O, N, or F. Then the second test is that the electronegative atom in one of the molecules has to be connected to a hydrogen. That's why it's called a hydrogen bond. And the electronegative atom on the other molecule must have at least one electron pair. So we're going to look at some of these examples and see if it meets the criterion. Okay, so the first one we're going to look at is methanol. Okay, so methanol here is got an electronegative oxygen attached to a hydrogen. Okay, so let's look and see. It's got an oxygen, nitrogen, or fluorine, so that's fine, and it is attached to a hydrogen. So it is a compound that could bond between another electronegative atom in another molecule. So the question is between molecules of the compound. So let's say you've got two of these methanols. Could they act together to where one molecule of methanol is having some kind of an attraction for another one of methanol? And I see oxygen and I see hydrogen, so yes, I see that they would be that would be possible. Between molecules of the compound and molecules of water. All right, so if you remember, water is going to be like this. It's two hydrogens and an oxygen. So if you look at the first oxygen, it's electronegative and has at least one lone pair. It has two. Water also is attached to hydrogen, and it also has at least one lone pair. So yes, this would also attach or attract to water. Okay. The second one is hydrobromic acid. Okay, so HBRO. So the first test, is there an oxygen, nitrogen, or fluorine in it? Yes. Okay, is it bound to a hydrogen? Yes. So will they react one to another? So in a jar full of this stuff, is one molecule going to have an attraction for another molecule? What this does is it makes it harder to boil. So the boiling point goes up because these molecules are stuck together. They're sticky, and they don't want to leave each other. They have to be pried away from each other like Velcro. And so all kinds of things happen in the properties like boiling and other things. So this one has got oxygen. It's got Br. It's got O. I would say yes. It certainly react with water because this water has a lone pair on the oxygen. Okay. And then the last one is hydrogen iodide. Well, I see a hydrogen, and you think hydrogen bonding has to have a hydrogen. That's true. Is there an electronegative atom there? Is there an oxygen, nitrogen, or fluorine? No, I don't see one. What about its attraction to water? Water has a hydrogen, water has an oxygen. Well, it's fine, so it would be okay, but there's no electronegative atom in it for the water to attach to or stick to. Okay, so this would be no. There isn't one between the compounds because that hydrogen doesn't have anything to pull with. There's no electronegative to pull the electrons with. And then between that molecule and water, the answer would be no. Okay, so pretty simple question here. I think you can get this pretty good.